Work problems we will go ahead and look at here. Depending how things are going, we may or may not be looking at this as being part of what we're doing on our test or on our homework, but probably good to look at just for something else anyway. So for problem 3, Amy can paint a loft apartment in 7 hours. Jeremy can paint a loft apartment of the same size in 9 hours. If they work together, how long will it take them to paint a third loft apartment of the same size? So what they're doing in this problem is finding out, like it says here, finding out what fraction of the loft each of them can paint in 1 hour, and then we can solve a rational equation. So the deal is, if one of them it takes 7 hours, then they could paint 1/7 in 1 hour. The other person, it takes 9 hours, so they could paint 1/9 of it in an hour. And so we're going to say that equals 1 over t, and that's like their combined rate that it takes them to paint this, or the combined fraction that they could paint in 1 hour. So this is our equation, and so what we're going to do, like we've been doing, we can multiply to get rid of the denominators. So common denominator would be 63t. So if you multiply by 63t on both sides, and then on the left side you'll be able to combine like terms after you do that. That would be 16t equals 63. So t equals 63 over 16. And that means that would be 3 and 15/16. So it would take, by this calculation, 3 and 15/16 hours to paint the apartment together. So if you look at the got at 3, one hose can fill a pool in 12 hours, another hose can fill the same pool in 8 hours. How long will it take for both hoses to fill the pool together? So for the first hose, it's 1/12 in an hour, and the second one is 1/8 in an hour, and we're trying to figure out all together. So similar idea with these denominators. Technically with 8 and 12 we can get 48 to work, so we can multiply by 48t on both sides. If you don't see that, if you did 96, that would work also. So if you distribute this, this would be 4t plus 6t, which would be 10t. And dividing by 10, normally we're not going to go with decimals here, but this one, dividing by 10, would just move your decimal over one spot to the left, so that would be 4.8 hours. Page 694, continuing section 11.5 on solving rational equations. If you look at problem 4, they are telling us that some rational equations are proportions, and you can solve them by using the cross products property. In other words, cross multiplying. That's fine, but I guess my argument here would be, how many things do you want to remember how to do? Do you want to remember 2 separate ideas, or do you want to just remember one thing? And if I'm given the choice, I'm going to say, if it's not hurting anything else, I'm just going to remember one thing instead of two things. So basically what I would do is say, yeah, it's a proportion, but I don't really care because it still has fractions on both sides. And we did fractions on both sides yesterday, and we just said, let's multiply to clear out our denominators. So I would just say, common denominator, we could do x plus 2 times x plus 1. We can multiply by that on both sides. And then the left side, x plus 2's will cancel. On the right side, x plus 1's will cancel. And then I'm going to rewrite this just to have the monomial in front of the binomial. So that'd be 4 times the quantity x plus 1, and then 3 times the quantity x plus 2. And if you'll notice in your book, they have the same thing, which is what I've talked to you guys about before. When you're doing cross multiplication, this is really what's happening. Basically, is they're saying, I don't really care what the denominators are. I'm just going to multiply them together, even if it's not the least common denominator. I'm just going to multiply to clear out the fractions. So I would argue that this way of what we're doing, looking for the common denominator, rather than just cross multiplying and just blindly saying, I'm just going to get whatever numbers I get. Potentially on some problems, if it's not the worst case scenario where you have to multiply the denominators together to get a least common denominator, you might end up with smaller numbers this way than by cross multiplying. If you want to cross multiply, that's fine. But like I said, it's basically two things to remember then. You have to remember, oh, it's this, so I'm going to multiply by the least common denominator. Or, oh, it's a proportion, so I'm going to cross multiply. Well, like I said, if you want to, you can just say, it's got fractions and it's got an equation. I'm just going to multiply by the common denominator, and I'm going to multiply by the common denominator. And I really don't care which it is. I'm going to do the same thing. Okay. At that point, it's just distributing and getting your variable on one side. And then normally we would have to divide at the end, but since we have a 1x, that's the same as x. So that would be our answer. And then you can always substitute that back in. That's the nice thing on these problems. I haven't been doing a whole lot of this to show you, but when you get x equals 2, if you have time, put that back in the equation. Put a 2 back in place of x and see what you get. So that's 4/4, that's 3/3. Is 4/4 equal to 3/3? And the answer is yes, because those are both equivalent to 1. So if we look at the got it number 4, they want us to find the solution or solutions, and reminding us to check our solutions here. So for part A, we'll look at what they've given us here. So one option we have here is we can multiply to get rid of our denominators like we did earlier in the section. So we can multiply by b plus 2 times b minus 2 on both sides. On the left side, the b plus 2's will cancel. On the right side, the b minus 2's will cancel. And I'm going to rewrite this just because there's a lot going on there. So at this point we can distribute. On the left side we would get 3b minus 6. On the right side we would get 5b plus 10. At this point we can try to get our variable on one side. So if you get rid of the smaller coefficient variable, that will keep things positive. Then we can go ahead and subtract 10 on both sides. To get the variable by itself, and then they're multiplying, so we divide by 2. And b equals negative 8. Once again, to check your solution, you can substitute negative 8 in both fractions. The first one, if you do that, would give you 3 over negative 6, and the second one would give you 5 over negative 10, and both of those are equivalent to negative 1/2. So we know we've got the right answer. Then if we look at part B, same idea. So we're trying to solve this. So to start with, if we want to clear out our fractions here, we can multiply on both sides by 3 times quantity c minus 4. So on the left side, we can cancel out the 3's. On the right side, we can cancel out the c minus 4's. And again, I'm just going to rewrite this. Then we can multiply here on the left side would be c squared minus 4c. On the right side would be 21. Then we've got a squared term and a c term, so we're going to want to set this equal to 0. And hopefully we'll be able to factor here in a minute. So try to factor into two binomials. There is no GCF. That would be the first thing we should look for before we try to factor, just to make it easier on ourselves. So we know we need c times c to get c squared. Since it's a minus 21, one sign has to be positive, the other has to be negative. Notice we do have more negatives here than positives. Looking at our closest factors would be 3 and 7, and we need more negatives. So I'm going to put the 7 with the negative, or the subtraction sign, 3 with the positive. And if you work that out, look at your middle terms. That's minus 7c plus 3c gives us minus 4c. So that works. And so that means either c plus 3 equals 0 or c minus 7 equals 0, which means c equals negative 3. Or c equals 7. A problem like this, we have to really be careful, because if you'll notice in the original problem, we did not have a c squared term, and when we multiplied, we ended up getting a c squared term. A lot of times when that happens, we end up with an extraneous solution. We end up with a solution that doesn't work. In this case, again, you could substitute those back in, but both of those will work. They both end up working on this problem, so we're actually okay, but we will be talking in a minute about extraneous solutions. If we look at problem 5, just talks again about extraneous solutions, where when we work these out, we might get an extra solution that actually is not a solution to the equation. So if you look at problem 5, they worked that out. And really this one, just to show you something different, this doesn't happen very often, but just to mention it, since the denominators are the same, you could have just said, well, if the denominators are the same and they're equal, it must mean the numerators are the same. So we technically could have just said 6 equals x plus 3. We could have subtracted 3 and we'd get x equals 3 and we'd be done. Anyway, they didn't do that, which, you know, that's fine. It's just extra work, but it's very rare that you would ever have a problem where the denominators are the same anyway. Anyway, so they worked this out and they ended up getting either 3 or negative 5. So they worked it out. They tried 3 and it worked. Then they tried negative 5. Negative 5 did not work. So negative 5 was an extraneous solution. So 3 would be the only solution for that problem. So let's look at the got it 5. One thing a little different on this problem is if you'll notice in the first denominator, they have a squared term and it's a binomial, which isn't always going to be able to do anything. But on this problem, that's actually a difference of squares. So that would be able to be factored as x plus 2 times x minus 2, which could help us out that we don't have to get so crazy with multiplying to get rid of our denominators. And that's a case where if you cross multiplied, then you wouldn't necessarily have to worry about that part, I guess. So I guess this is one case where cross multiplying could come up, as you could argue being a little bit simpler maybe. So we can then multiply to get rid of our denominators. So on the left side, well, we just need to multiply then by x plus 2 times x minus 2. If you didn't have it factored like that, you might have thought, oh, I need to multiply by x squared minus 4 times x minus 2. And it should still work for you, it's just this is going to be a little bit less involved. So on the left side, everything cancels there. So that would just leave us with x minus 4. On the right side, the x minus 2's cancel, and we would be left with negative 2. And I guess we're going to have to work it out the way that they said, because I made a mistake here, was that on the right side we should have been multiplying by x plus 2 times x minus 2. So I forgot the x plus 2 over there. So that would be negative 2x minus 4. And then we can add 2x on both sides. Then we can add 4 on both sides and divide by 3. And so x equals 0. One thing about that is we did this problem differently. And this is actually a case for that it's actually maybe a little bit less work for you if you don't just cross multiply blindly on these problems. We'll go ahead and look at it the other way if we cross multiplied, just to show you how that would have worked out, because then we will be practicing with extraneous solutions. So going back to the original problem, if instead of trying to factor that first denominator, if we either didn't factor it or if we just cross multiplied, let's say we just didn't factor it. So let's say we thought we needed x squared minus 4 times x minus 2 on both sides. Okay, so this will work. It's just that this is what we're going to end up getting an extraneous solution. So on the left side, x squared minus 4's cancel. On the right side, x minus 2's cancel. And then we can FOIL this out. So the left side would be x squared minus 4x minus 2x plus 8. On the right side would be negative 2x squared plus 8. If you combine like terms on the left side would be x squared minus 6x plus 8. We have squared terms, x terms, and constants, so we're going to want to set this equal to 0. If you like positive coefficients, I would suggest getting it to the left side, so that would be 3x squared minus 6x, and then you can subtract x on both sides, or subtract 8 on both sides rather, which those end up canceling actually. At this point, we actually have something we haven't seen in a while, which is the greatest common factor that we can factor out. So actually, these have both a 3x in common that we can factor out, and that would leave us with x minus 2. And so that means either, if these things multiplied together equal 0, means either 3x equals 0 or x minus 2 equals 0. So if you solve this, the first one says x equals 0, and the second one says x equals 2. So you look at that and you say, okay, those are my answers. Well, not so fast. We got to check those answers and make sure they work. And really, anytime you work out a problem, it's good to check your answer just to make sure you've done it correctly. But especially if you work one of these out and you get 2 answers, that's a case where you may even end up with an extraneous solution. Okay, so if we put in a 0 first, that's just going to give me basically negative 4 over negative 4, and negative 2 over negative 2. So both of those are equivalent to 1. So that works. Then we could try putting in a 2. So we try putting in a 2 for x. And we've got a problem. You look at this and you might say, well, they both equal the same thing. They both equal negative 2 over 0. The problem is that we don't want to divide by 0. That would be undefined. And so not wanting our denominator to be equal to 0, x equals 2 does not work. So x equals 0 would be our solution. And again, just showing you how not cross multiplying, if you factor anyway, could be actually a simpler result. Cross multiplying, we would have been doing it this way for sure. So if we look at the lesson check number 3, this is actually very similar to the problem we just did. So if you notice this one, you could factor that second denominator as x plus 2 times x minus 2. And then it's basically the same process that we just did. So again, if you notice, to factor that, that'll actually save you from having to deal with the extraneous solution on this problem. So now we could add 2x on both sides. Remember, this is like a 1x over here. Then we could subtract 4 on both sides. And divide by 3. And we get x equals 0. It's only one solution, so we're probably safe with that. But if you wanted to substitute that back in the original equation, you'd end up getting -2 over 2, which is equivalent to -1. And then on the right side, you get 4 over -4, which is also equivalent to -1. So that is correct. Again, if you wouldn't have factored it out, if you would have just multiplied by both denominators, you would have ended up with an extraneous solution for this problem. One more thing we're going to do here, we're going to look at problem number 38. And this isn't necessarily quite in line maybe with what we did today, but just a good problem for us to look at just to get some more practice with this. So in this problem, if you see the trinomial, this might look a little intimidating at first, but that trinomial can actually be factored as u plus 2 times u minus 3, which just so happened to be the other denominators that we had in this problem. And so at that point, we can go ahead and multiply to get rid of our denominators since we have an equation. So we can multiply by u plus 2 times u minus 3 on both sides. On the left side, since there's only the one fraction there, you can go ahead and cancel out the u plus 2's. And that would leave us u minus 3 times u plus 1. On the right side, if you can imagine it, I'm going to try and do this without rewriting all that because that's a lot of stuff to rewrite and then distribute, which if you need to, that's fine. The first ones, the u minus 3's would cancel. So I'd have -1 times u plus 2. On the second one, both of them would cancel. U plus 2 and u minus 3 would both cancel. We'd be left with u minus 1. And we don't really need parentheses around the u plus or u minus 1 there. Notice there's an addition sign in between that, so don't try to FOIL that out or distribute that all out. So on the left side, we would need to FOIL that. On the right side, we just need to distribute the -1. So on the left side, we can distribute this. And then combine your middle terms together, and that would be u squared minus 2u minus 3. On the right side, we can distribute would be -1u minus 2 plus u minus 1. And then we can combine like terms together. So on the right side, if you combine these together, the u's are going to cancel. And we would end up with -3. Notice again here we have a squared term and a u term and also a constant. So we're going to want to set this equal to 0. Most of the stuff's already on the left side, so if we add 3 on both sides, that'll get it set equal to 0. So now we have a GCF, which is u, so that factors as u times the quantity u minus 2, which means either u equals 0 or u minus 2 equals 0. So u equals 0 or u equals 2. And at that point, we would want to substitute that back in. In this case, without going through all of that, both of those end up working. We actually do not have an extraneous solution with that. And so that should be our answer. So this gives you an idea of how to work with solving rational equations.